Okay guys, so I'm going to be gone Thursday and Friday, and I wanted to make sure you were still on track. So the cool thing about this, hopefully the substitute is already plugged in or pulled up the video. You can pause me at any time. I'm going to give somebody the clicker. They're in charge of pausing or playing, but I'm expecting for this to take about 10 minutes. So we're going to start on page 9, which is lesson 5.4, what is a chemical reaction? Or what is a chemical equation, better known as. Now there are 4 main indicators that we have already gone over. I showed some demos yesterday in class. I'm sorry I'm not able to do them on camera. But you already know. If we see bubbles, that's a chemical reaction. If we see something change colors, for example, I think we did lead nitrate and potassium iodide. Remember we had 2 clear liquids, we added them together and they turned yellow. Chemical change. Any release of energy, this could be maybe something blows up or heat is released. That is an example of a chemical change taking place. And then we're going to talk more about this word precipitate. What I want you to know and maybe add to your notes, again on page 9, this means there's going to be a solid that forms. So we add 2 liquids, and after we mix it for a while, something solid comes out, like a little whitish powder settles to the ground. Now, probably from middle school, you've seen a chemical equation written before, so this is probably a review. But if not, most of the time we always have the reactants on the left side, and we've got the products, what is made, on the right. And we typically add a little bit of jargon. This arrow can mean a number of things. It either means makes, yields, or forms. So you'll hear me in class say, methane and oxygen yield carbon dioxide and water, or methane and oxygen make carbon dioxide and water. I just want you to know they're all the same thing. You'll also see sometimes we'll have a species here and we'll put a plus sign. This basically means we're mixing 2 reactants. This plus basically can mean and, or maybe even with. And when we write equations given the words, you'll see what I mean when we're going through this. So, we're going to move over here and we're going to take a look at this equation. We're going to kind of dissect what is being said here. This is HCl, or better known as hydrochloric acid. Extremely corrosive stuff. You do not want to get this stuff on your hands. And it's got a plus sign. Hydrochloric plus, we know plus means and. So this is hydrochloric acid and zinc. And zinc is a metal. Hydrochloric acid and zinc metal, and then we got that arrow, and we all know that arrow means yields, makes, forms, whatever you want to do. Makes. And we've got something called H2, which is hydrogen gas. And I realize you have this written down in your course pack, so I'm not asking you to write this down. And then there is another plus sign, so that's and it's zinc. ZnCl, metal, non-metal. The metal name stays the same. We change the Cl, all we do is add an I, so this is zinc chloride. Okay? So what we've gone over so far, how can we tell is a chemical reaction taking place? What does an equation look like when it's written? What does each part mean? And then we've done an example. Now let's go ahead and work through a few examples in class. There is one thing that we've got to do, or we've got to recognize beforehand. Okay, so I'm about halfway down on page 9 right now, and the reaction I give you is NaCl, better known as table salt, which you put on your food, makes or forms Na sodium metal plus chlorine. So basically this is a decomposition reaction because these things are breaking apart. We'll cover that more in 5.7. Now, chlorine is a special type of gas. This is called a diatomic gas. And many of you guys who just killed Unit 4, you knew exactly what was going on. You know that di, mono means, di means, tri means. So di means, my camera, my filmer is signaling it to me, di means 2. And basically diatomic means 2 atoms, meaning these gases never like to chill by themselves. They always got to have a buddy that they're linked up to. So chlorine, when I write chlorine or when I see chlorine gas, it is actually always written down as Cl2. Okay? And chlorine's not the only one. There's actually a whole bunch that you got to remember, but I think I have the list up there, diatomic molecules. And it's on your paper, you've already got it. Here's how you remember them. Old German guy named Mr. Brinkelhoff. So Mr. Brinkelhoff, you just got to remember how to spell his name. B-R-I-N-C-L-H-O-F. This is Mr. Brinkelhoff, and he is the diatomic guy. Now Mr. Brinkelhoff, if you remember, check it out. We've got bromine, we've got iodine, nitrogen, chlorine, hydrogen, oxygen, and fluorine. All of these are diatomic, meaning two atoms. They can only exist in two. So whenever we hear these, we always add two. That's going to be important when we're writing equations given the names. Okay? So, let's get down there. Let's do an example here. Let's do an example. All right, Larry.
Pardon me?
Yeah.
I was told, I need a desk, and I was told to get one from your robotics room and to get the key from you.
Major Monroe's got it.
Okay.
Yeah, sorry. Okay, so let's go ahead and look at an example. I'm now on page 10, and I'm probably running out of time. I'll make this brief. They tell us that ethanol, which is an alcohol, ethanol, and they give us this because I don't expect you to memorize these yet, not until we get to organic chemistry at the end of the year, is burned in the presence of oxygen gas, and it forms carbon dioxide and water, gas. Okay. So, let's go through this, and let's get ready to write the equation. I'm going to do it over here if you can see at least. Ethanol, they give us the reaction, is C2H5OH. So now I'm writing this down below my notes. Is burned in the presence of oxygen. This is another saying, ethanol and oxygen are burned together. So we are going to put a plus sign, meaning ethanol and oxygen. Well, we all know oxygen is symbol O. But we got to remember Mr. Brinkelhoff, right? Mr. Brinkelhoff over here, O is in his name. So O is a diatomic gas. So we do not write O by itself. In fact, we always write O as O2 because it is a diatomic gas. In the presence of oxygen gas, and it forms, that's the key word, the arrow, forms, makes, yields, it forms carbon dioxide. And if you're good at Unit 4, you know carbon is C, dioxygen means 2, so there is 2 O's, CO2, plus water gas, and most of us have committed to memory already, H2O. Okay? So that's how we go through it. Now, I want you to know, this is not balanced. This is not balanced right now. That is something we're going to do in 5.5 here in a little bit. Okay? I'm not going to write out the other example because that took a lot of time, but I am going to do the few with you. So now I'm on to the next example. Wrap up here. New piece of chalk. And it says, solid calcium carbonate is heated and turns into solid calcium oxide and carbon dioxide gas. So I'm going to write down my species. This is the next example. And I've got calcium carbonate being heated, and it's making calcium oxide, solid calcium oxide, and, which means plus, carbon dioxide gas. Okay? Well, calcium carbonate, if we remember, this is a polyatomic ion. This is what you were supposed to memorize a long time ago. If you don't, pull out that chart, look at it. Calcium, we know, is Ca. It's in group 2, so that means it has a charge of Group 1, oh yeah, groups are the same as the charges, so this is 2 plus, because it's in group 2. Carbonate, if I looked at my list, and I know, is CO3, 2 minus. So I've got 2 plus, 2 minus. They cancel out charges easily, so they just need 1 and 1. Or I could do the crisscross rule. It doesn't matter, but this is going to be calcium carbonate. And it makes calcium oxide. Oh, well, I got to check and do the crisscross rule here again. Calcium is 2 plus, oxygen is 2 minus. Well, that's good. Crisscross. I'm going to get Ca2O2. I can reduce that. So that's just going to be CaO, which you guys are pretty good at by now. And carbon dioxide, which we already did, and that's easy because that's CO2. Okay. One last example. It says aqueous silver nitrate. Now we're going to talk about what these aqueous thing means here in a second, but I'm not worried about it right now. Silver nitrate reacts with aqueous sodium chromate. So we've got sodium chromate to make solid silver chromate. Oh, this is exhausting. Good thing I wrote it for you. And sodium nitrate. Okay, so silver, Ag. Ag is always plus 1. Nitrate, NO3. Minus. Crisscross that. 1 and 1. That's easy. 1, 1. This is Ag, NO3. Plus sodium chromate. Well, Na is plus 1. I think CrO4 is minus 1. I'm almost positive. I don't have my notes with me, but I bet my dog's life on it. I don't have a dog. So, I want to do that. NaCrO4. Okay, silver nitrate plus sodium chromate. Notice, guys, I told you, these polyatomic ions are coming back into play. Silver chromate, well, that's Ag. CrO4 plus sodium nitrate. Sodium nitrate, still same thing, NO3. And then that's that. Okay, so in the next lesson we're going to go over a little bit more on balancing these equations and see if they actually satisfy the law of conservation of mass. But hopefully by now, if you'll follow me, you understand what is a chemical equation. You know that you can tell when a chemical reaction is taking place based on these 4 indicators. You know that reactants are written before the arrow. You know the arrow means makes, yields, forms, etc. You know that when we're mixing things, we have a plus, which means and or with. And now, if you follow me, you know how to take a sentence and break it down. And the important thing, I think the key takeaway to remember here, is that oxygen is a diatomic gas. And all we've got to remember there is our Brinkelhoff elements. Brinkelhoff. All these guys are the diatomic gas. And I'll tell you something a little bit later called the magic 7. And that's another way if you don't like learning a little German and chemistry. Anyway, I hope this goes well. You have practice, I believe. Well, we're going to have to do the next part of the lesson before you do the practice. All right, thanks. Done. How long was that?
14 minutes,
14
2
minutes.
seconds.
Jeez.
Crap. Ugh.